So good afternoon. Thanks for coming to my talk. So my name is Ying Xiong. I'm Chief Architect of Cloud Platform at Huawei. So in this talk, I'm going to talk about the project we're doing is called Edge Cloud and share some experience we had with you about how to use the Kubernetes to manage the nodes on the edge and how run the applications or containers or serverless functions on the edge platforms. So a little bit more about myself. So again, I'm a chief architect of a platform called PaaS, Pizza as a Services. So platform as a services is cloud native one that we have. So that's my main responsibility. Besides that, I also manage a lab here in Seattle for Huawei. It's called Cloud Lab. We do kind of interesting project in the lab, including the cloud networking and cloud storage and some of the AI, of course. So we're also hiring. So if you know somebody that's looking for a job, hey, talk to me. We have some hiring there. So Huawei actually is a founding member of CNCF Foundation. So we are, I'm part of the kind of board members representing Huawei in the CNCF Foundation. So we're doing a lot of projects with CNCF, including Kubernetes. We contribute a lot in the Kubernetes. We're also doing some other projects. Actually, we're also doing Istio, try to work on the Istio side too. Before Huawei, I worked for Microsoft. This is Seattle. Everyone has worked for Microsoft at some point. Before that, I worked for AT&T. Anyway, so again, it's talking about the cloud, edge cloud. So what it is, edge cloud? And of course, pretty sure that you have your own definitions. So everyone has own definitions. For us, we define the edge cloud as those characteristics. One is the computing resource at the edge that managed by the cloud. So I say managed by cloud. If you have edge in the computer that's not managed by cloud, we think that's not part of our scope for our project. So that's what we call edge cloud. And you could call edge computing, it's not managed by cloud. And so that we think that edge cloud is an extension of a central cloud. This morning in this on-stage interview talk with Mark from Microsoft, he's talking about the agent is the train, and that's where it's extension of the cloud. So we think it's the same thing here. Also, the resource ownership and the servers on the edge could owned by cloud provider. The Huawei is actually we have our own public cloud, or owned by customers. So that's a little bit different than the centralized cloud where the servers are owned by the cloud providers. Now, when they're owned by customer, and in order to actually make the edge cloud work, the customer has to authorize the cloud providers to manage the resources, which is the edge servers here on the edge. So that's kind of a little bit different than that. Also, app are scheduled and deployed onto the edge from cloud. So that's not pre-installed app in the edge servers. That's not locally installed or deployed. It's actually deployed from the cloud. So that's another kind of characteristic for the edge cloud perspective. That is the bi-directional communication between the edge and the cloud. You can look at the CDN is kind of one direction, right, from cloud to the edge. But then that's it. So in the edge cloud, in our scope, it has to be bi-directional communication between the edge. We have edge information about the applications, about the status of the nodes has to be sent back to the cloud, so cloud be able to manage that. So that's the edge cloud that we define, and this is the project we're doing. Now, why we're doing edge cloud? So I don't think I have to convince you why we're doing that. Microsoft just announced the IoT edge cloud platform, and again, this morning in the on-stage interview with Mark from the Microsoft, he's talking about the trends of edge, whether it's for data privacy, whether it's just huge data, or whether it's just the latency requirement for your applications or the network bandwidth you have that is not good enough to the cloud. And those are all the reasons they wanted the cloud. Now, for us, we have a couple of scenarios that we want to do edge cloud. One is the video surveillance scenarios we have. This one actually is very popular in China, where if you got a chance to went to some of the cities, big cities in China, almost every traffic light there has videos. There's surveillance to monitor the traffic, monitor whoever to violate the traffic. So there's a lot, and a lot of resident communities in China that has the videos surveillance there in the gate or in the community door where monitor, suspicious people is going to come back and through, and all the cars, the trap back and forth between the enter the community and out of the communities. And that's one of the scenarios we want to do. And in fact, with part of the project, we're doing a POC with some of the customers actually doing that, helping them doing that. Another one is industrial IoT scenarios, and I don't have to emphasize this. A lot of our customers, they are IoT scenarios. They want to run these applications on this very little, sensors, and we call H2. We can consider as H2. All the sensors connect to a servers. The servers are running the H applications. Huawei also has the smart home scenarios, which is what we actually manufacture another smart home watches, smart home appliances, and this is where they also want to run some applications or serverless functions inside of the home smart appliance. So these are scenarios we want to do edge cloud. Now, some of the challenge we have here. First is, of course, it's a resource constraints. It's not in the centralized data center. So we've seen a range of computing the edge nodes from 64 megabytes memory to 250 megabytes computer servers that on the edge. So we need to manage this. So it's a range of resources, computer nodes. Well, even with a large, powerful servers on the edge, we have a customer tell us that they only assign a couple hundred of megabytes for us to deploy the platform there because they want to need more power, more memory to run the application itself, especially for AI applications over there. So for us, that's the challenge is we have to make the platform really, really lightweight to run on those different type of the edge nodes that has different set of configurations in terms of resource perspective. The second challenge is network stability. As you say that the servers, the resources, the edge, on the edge where it's really, you can't assume that it's always connected. You will be offline sometimes, you're connected. So that actually posts our requirements to us. Basically say, whenever you lost the network connection, you have to, the application running on the nodes has to be managed itself. That means has to manage itself. So we have to have the solutions to handle those scenarios, and that's one of the challenges I have. Especially, in fact, some of the edge customer we have, the customer actually own the edge servers, edge nodes, but this server is not in the public network, in the private network. So how do you manage that from the cloud when the servers on the network is not public? So that's another challenge we have. We'll have some solution there I can talk about later on this. It just that we have the scenario where the edge nodes is not accessible from cloud. And the other side of the challenge is the manage the multi-tenancy on that cloud, on the edge resource from the cloud. You think about the edge could have different. It's actually we have a services called edge cloud services actually manage the edge for different customers, which means different tenants, right? And then now you imagine could be a lot of the edge nodes, and each edge node has to be isolate each other, even go through the same channel in the or same services in the public cloud. So that's manage this multi-tenant edge. It's kind of a challenge for us. We have to make sure that if the customer try to deploy the applications on the edge where you deploy to the other customer edge, that will violate this multi-tenancy policy, right? We don't want to do that. You don't want this to happen. We also do have requirements that how to communicate edge to edge. So they'll have edge cloud, edge servers on the one side, another edge server on the other side. They want to communicate each other in case their connection is dropped or connection is lost from the cloud. So we do have those requirements there too. So that's kind of all the challenge we have for this project that we are doing, edge cloud. So The first thing we try the Kubernetes. Since we already, Huawei has our own public cloud services. We have container services based on Kubernetes. So the first thing we say, okay, let's try to using the Kubernetes that manage the nodes that on the edge, right? And then actually the Kubernetes is not designed to manage nodes for the edge. So, but this is the first thing we try, and then we encounter a couple of problems. The first is what happens when the edge nodes the loss of network connection. That's obvious. And based on the design of Kubernetes, where if you lose the connection, you cannot update the node status to the cluster on the Kubernetes. Kubernetes think that load is not there, will eject the node from the cloud, from the clusters. So then you cannot deploy applications there in the node. So those are the problems that they have when you actually using the Kubernetes to manage the nodes that are actually away from data centers on the edge. They also have other problems too. And the applications running on the node, normally we send the status, right, kind of heartbeat to the cloud on the cluster, we call Kubernetes masters. Now, once the connection is lost, what happened to this status? What will happen to the app? You know what? The Kubernetes, which is running on the edge, will actually shut down the applications. They don't know what they should do for the application or for their containers. So those are the problems we encountered when we first tried that. Second is a lot of applications running this platform on the edge, and they want to send the data to the cloud, to the cloud. No, we don't have a platform, or Kubernetes doesn't have this built-in mechanism in the platform to provide the channel for applications to send the data out to the cloud. They have to do it themselves. But if we run many applications there, and then every application has to do their own. So we would like to have the platform that actually provide the capability that the communication channels for the data itself. So for applications to send out, they put the data there, they automatically guarantee they manage sync back to the cloud or send to the cloud. There's no serverless functions at the edge support. That's, of course, is not part of Kubernetes. But we do have those requirements where we want to run the serverless functions push to the edge. The servers are running. Of course, when just push the metadata, the functional definitions into the edge. Now, when this function running is based on the events happen on the edge, not happen in the cloud. So we want that have kind of capabilities in our platform. So I'm going to talk about later about this. This kind of challenge we have when we first try the using Kubernetes manage the edge nodes away from the cloud. So based on those challenges, our current requirement, and we come up with this architectures that we have. And we still try to leverage as much as possible on the cloud side for the using the Kubernetes itself. We think this very flexible architecture we can extend it for the cloud edge. So in that architecture, we first realized that we have to build a communication channels, the robust communication channels between the edge and the cloud, and that's fundamental. We want to make sure that that communication channel is reliable and it's scalable on the cloud side. It's assumed that we're running many nodes, managing many edge nodes from the cloud. So that means that if the network connection is lost, this communication channel has to keep trying to establish the connections, and when it's connected to the cloud. So we have to make that. So first thing we build up is we call CloudHub or Edge Hub. One is on the cloud side, one is on the edge side. We can make sure this communication is always open. So for the data or for management plan or control plan, the information back and forth between the edge and the cloud. So I can talk about a little about that. The second kind of components we build for this architecture is edge controller, we call, which edge controller is actually using the Kubernetes controller plugin, building this edge controller. What the controller do is on behalf of edge nodes, to interact with Kubernetes cluster on the cloud. So it's not only kind of virtual nodes, you will say, the virtual edge nodes they have, but that controller is on behalf of edge nodes to manage the connections, manage the data, manage the command from the cloud, push functions to the edge. So we call edge controller. The second is, we mentioned that when the network is on the edge side, when the network is not connected or offline, and in order to do that, we have to build a metadata sync and into the from the cloud back to the edge, so that when the connection is gone, we still have a metadata, which including the functional definition or the container images or the what we call application specification or application configuration. So we can the edge itself can manage themselves, can restart it. The functions or the containers on the edge. So that's why we have to build this edge metadata sync. The next component we have to build is we call Kubernetes Edge, which is the agent, which we call a agent on the edge, which is actually optimized Kubernetes. If you know the Kubernetes is a Kubernetes running on the nodes, so it's optimized the agents on the edge where actually manage the applications and the containers and the functions, serverless functions on the edge. And you basically watch, if you know the Kubernetes, you basically watch ECCD, which is have the application specifications there, and as a local store, and watch there, and then try to manage the applications. Start up the application, upgrade the application, or in this case, it's containers or the functions. You also listen to the events from the devices. If this is the edge, that when the events happen, it will trigger it will manage or stop some functions to process the events. So that's kind of what we call it. Kubernetes Edge is again optimize the Kubernetes to manage the life cycles on the edge. I can talk about a little more on this on the later slides. The last component we built for that whole architecture we have is the event hub. There's basically currently we support HTTP and MQTT, which basically that we have events for your device from the devices that to the edge. Like your temperature change, whatever the device, they connect to the edge, and they will send out the events. And that events will trigger the functions to run and to process the events in these functions locally on the edge. So that's the kind of high-level architecture we have. By no means this is kind of only or best architecture we have. We are working with some of the customer POC, doing POC to verify this architecture, especially from kind of edge perspective. So latest, the rest of slides, I'll just talk about a little bit more on those components we have. First, I mentioned there is a CloudHub and the Edge Hub, which is, we built it as a custom protocol, network protocol over TCP/IP, that designed for edge communication and the edge and the cloud communication. And the key here is make it reliable, make it sure that it's fault tolerance. Because that when you lose a connection, this hub has to try to make a connection to the cloud and always make the connections, try to make a connection to the cloud. Especially if the edge is in the private network, has and no access from the cloud. So this hub, basically on this side, in this case, is the edge hub, have to make a connections to the cloud, from the edge to the cloud, and keep the connections there. This is that's called long connections. So that when a message or command try to push it from cloud to the edge, it will leverage this connection. And this is sometimes called the multiplexing the channels, where you make a connection from the edge to the cloud and keep it connection, so that when the cloud side want to push some information or some command back to the edge, you can leverage the connections there. So that's kind of key part of this edge hub on the cloud hub. Again, is a very reliable directional multiplex channel, and then again with scalability on the cloud side. We mentioned that this edge on this servers on the edge, it could belongs to different tenant, and then we have to manage it, for security, for other reasons, and so that's really a multi-tenancy. Even for the connections, you have connections that come from different tenants. Edge server to the cloud, we have to make sure those connections are isolated each other so they don't impact each other. So that we have to build in that capability inside of this communication hub or channels. Today, in our kind of POC with customer, we do support HTTP with this communication between this cloud and the edge. We plan to support WebSocket and gRPC, of course, native TCP/IP. That's we're working on that. For security, each node right now is very basic. Basically, each edge node using certificate to authenticate itself to the cloud, so they can, when the edge register himself to the cloud, we will download this certificate in the edge and make sure that's valid edge nodes that we manage from the cloud. So that's edge cloud, and this edge controller I mentioned earlier, which is the components on the cloud side. Again, is manage the edge nodes, including the register the new edge nodes. That's basically work on behalf of the edge nodes that work together with Kubernetes master in this case. So, for example, that in the users can using the standard Kubernetes API to deploy their applications from the cloud, right? Using the Kubernetes API. Then the edge controller will watch this change, watch this. Okay, this is a new application, a new pod, we call pod, right? Yeah, try to deploy, and then watch this and actually deploy to the edge nodes. And how to deploy? You will go through the cloud hub or the edge hub that we're talking about, and then push that specification into the nodes, and the node, the Kubernetes edge will take that and then store or start these containers on the edge. So that's how this whole process works. So the edge controller basically work on behalf of the edge nodes, and it could be work on behalf of one node or 100 nodes, and so it will be scalable to manage that many of nodes from Kubernetes perspective. At the same time, where the edge we call Kubernetes edge, which is running the agent running on the edge, you will actually do the heartbeat of the node itself. So the node status and the application status, which is container or pod status, we're keeping sync back to the Kubernetes and the cloud, and that where edge controller also watch that too. Edge controller also watch any status change about the nodes, the edge nodes, and the applications running on the nodes, and sync that into the Kubernetes masters too. And so with the KB sync. And so from outside perspective, it's standard Kubernetes API. Customer just deploy the application, but underneath it, go through this cloud hub or the edge hub and deploy the functions, manage the functions, or the containers on the edge nodes. So that's the whole idea, in fact. Metadata sync, and this is a kind of very important components we have in our architecture. It basically is designed for where the edge node is offline. And we want to make sure the applications running on the container running on the edge is still running. And if they crash, we still have ways to start up. And then if the node is actually disconnect from the cloud where the cloud sync, the node doesn't exist, but we don't want to then shut down the applications on there on the edge. So we have to sync the metadata there from the cloud to the edge. This we actually have using a trimmed down version of etcd. If you know the Kubernetes, the etcd is behind the store of the API server and the Kubernetes API server, and we kind of the etcd has kind of 3 layers itself, and one is the multi-version, the continuous control layer, which is like a store. We keep it that, and then we remove the gRPC, which is interface. We remove the wrapped consistency on which that piece. So we have a kind of mini version of etcd that has watch capabilities. We actually install that into the edge. Now the reason we're doing that is we have some edge, just like a Raspberry Pi, it's very small memory, so that we can run it on there. And in fact, I think we're already running on we try one of the POC, we try a demo. We actually just hosting the architecture on the edge. We actually run a Raspberry Pi. A Raspberry Pi is 128 meg memories of the devices running there. And the etcd minimum is just occupied by less than 1 megabyte memory is there. So that's the reason we're doing this trimmed down version of etcd. But it works actually pretty well on the edge side, where we have a Kubernetes edge which constantly watch this. So we don't change the behavior of the Kubernetes, which is we optimized for the Kubernetes edge. So at the same time, I think I saw say that again, the edge, the application, which is a part in this case, the spec change, including the new deployment, or the remove existing app. If the customer say I want to delete the app from running on this edge, they can call the API in the cloud, which is sync their actual specific metadata into the edge, and then Kubernetes edge will find out it, and they will delete or remove or shut down those applications or containers on the edge. So that's how the process works. That's one direction from cloud to edge. Now, from edge to cloud, you leverage the same channel, communication channel there. The Kubernetes edge has the same heartbeat capability like Kubernetes, where heartbeat, the node heartbeat information and the Kubernetes, the application status back to the cloud. So the Kubernetes master will have this have the information of there. The good for that is the customer, from customer perspective, I looking from a cloud side, I can see all these edge servers running there. I can see all the applications running on which application running on the which edge nodes. So I can manage and see, review from the cloud side. That's why we have to sync the data there from node to the cloud. Kubernetes edge, I mentioned a little bit that it's kind of manage the runtime environment for the edge nodes and manage the application lifecycle. Start it, stop it, and upgrade it, or restart it based on the events. So that's the Kubernetes edge. Again, it's an optimized version of Kubernetes and the manage the lifecycle for containers or functions. And they can work offline when network connection is lost. I mentioned that also. And it also responds to the edge. There's something we added to it is for the serverless functions. The event happened on the edge. And the event happened on the edge through the event channel where Kubernetes edge responds to the edge events and then start corresponding functions on the edge or containers on the edge. So we have, during the event registration on the edge, we have to keep a mapping between the events and the functions or containers. So that metadata also is created in the cloud, but again, sync back to the nodes. Now the nodes, of course, in the cloud, you manage a lot of nodes, hundreds or thousands of nodes. They are from different customers. Not all the nodes actually sync data, only sync the data that relate to the nodes, you sync it back to the nodes, not other stuff. So I think that's it. That's probably what I have for this, for my presentations. Okay. Any question? Yeah.
What is open source?
So in fact, that's a good question. We are in the process to try to open source Kubernetes in the and a communicating channel too. So we're not there yet, but we are trying to open source that. This is SainSafe. We'll plan to that. We have not talked to the SainSafe yet. Yeah, but that's the plan.
The question is, what are you using for functions? What are you using for functions runtime?
Well, function runtime, we have a couple of function runtime also. We're building, well, first of all, function, we also package as a container, so that's the same. Mm-hmm. And then, but we have a runtime for when the container start up, we have passive runtime, we build also, and the Java Go runtime there. So the runtime is already there. When the first node register with cloud, we download the runtime into the nodes.
So we have a research project taking open and applying to the edge, so that could be something.
That could be something, yes. Right now, so we build our own for the serverless functions there. The one piece I did not mention there is if the edge is very small, I mean, very lightweight, like 128 meg memories, we have a lightweight containers that run in these functions, all the applications. And that container actually conform to standards of OCI, but it's not standard Docker because in that scenario, standard Docker is still too large. The Docker runtime, if you're running Docker runtime, it's all 100, you're already 100 or maybe 200 megabytes already. Normally it's 100 megabytes already. So that's too big, in fact, and that in that scenarios. So we do have a nice version of containers we're working on for those scenarios. Yeah. Most of the services in the preview stage in our public cloud. If you actually go to Huawei public cloud, which is huaweicloud.com, we have a service called, I remember it's called Edge Cloud. I think it's called Edge Cloud Services. And then you will there have you can register nodes, start to play around with it. In fact, yeah. You want there? How to load balance the? I'm sorry. How to load balance the nodes, the edge nodes? That's a very good question. We do have one of the architecture we have. I did not show there is the Kubernetes master in the cloud. We could run many instances of that, and then when a node register to the cloud, we have a component that we call placement, which actually decide which clusters you will register with, so that each node only belongs to one cluster. And of course, we can run many clusters in the cloud. And that's where we manage the load balance, the edge node.
Is now turned on. Now, once again, any other questions? That is all. I believe that concludes our
Thank you.
DevOps and containers track for the day. Thank you for coming along. Hope you've enjoyed our speakers.